This is Algebra 2 with trig. This is the review for 7.1 to 7.4. This is page 5 and probably 6. A Dell computer costs $2,600. The value of the computer decreases by 15% each year. Write a model giving the cost C of the computer after T years. So we start at 2,600. 1 minus, so that's 100% of the cost, minus 15%. So we move the decimal spot 2 to the left, and that's why we have 0.15 to the T. So we could say that this was 0.85 to the T. How much will the computer be worth in 2 years? We would have a 2 for the years. And this is the calculator portion, so we're allowed to use our calculator on it. 2,600 to 0.85 to the second power. And that's going to be 1,878.5. And if this is money, we're going to say 50. After how many years will it be worth $600? Well, we can do this a couple different ways. We could do it on a graph. That'd probably be the quickest way. You could also use logarithms to help you calculate that value. So we have our 2,600, 0.85 to the x value. And what we want to see is when is this going to become $600? So it's decreasing in price. When will it be $600? So I'm going to look at our table and see when are we going to get close to 600, and that's around 9 years, a little bit less than 9 years. We'll be up at 600. So I'm going to make my x maximum a little bit more so we can be sure to get that full view of the 9. And I don't need to go up to 400,000. I only need to go up more than 600. So let's say 1,000. So now we're going to see the graph decreasing, and then we're going to see where the 600 is. We'll do our intersect, so that's second trace. It asks for the first curve. Yes, that's my equation. That's my other equation. My guess, that's good enough. So 9.02, though, that would be the amount of years. So what we're trying to do here, if we wanted to show some work, is we say 600 equals 2,600.85 to the T. And T would be approximately 9.02 years. I like you to be as accurate as you can and not just approximate it being 9 years. 9.02 is a little bit more official. Anne wants to buy a new couch in 3 years. The couch costs $1,500. How much should she deposit now at 6% compounded quarterly so that she'll have enough money to buy the couch? So she wants to have $1,500. How much should she deposit? That's her X amount. If she's going to get 1 plus 0.06 compounded quarterly. Quarterly, there are 4 quarters. So that's 4 times a year. And that needs to be in 3 years. So it's 4 every time you compound it for 3 years. So that's 12 times. So what we're going to see is 1,500. How much are we going to spend? 0.06 divided by 4. And we're going to add our 1 to that, so it's 1.015 to the 12. So when we raise that to the 12th, we get our 1,500 equals x 1.1956. Don't worry about how much you write in there, because we're going to say 1,500 divided by the answer. You want to use the real calculation, and that means you should deposit $1,200, and the rest of it, the bank will pay the rest. They will give it to you in interest over time. Okay, here we can use our calculator to determine the log of 7. So the log button is on your calculator next to the 7. Happens to put in 7. And that means 10 to the 0.8 value. I'll show you that here in a second. If we had 10 to the power of our answer, we should get exactly 7. So what that means, because the base was a 10, 10 to what power makes 7? 10 to the 0.84 makes 7. All right, this is an E question. So natural log has a base of E, and that is approximately 1.792. If we're rounding to the nearest thousandth, you got to look at the 10,000 to make that round. Then we're going to have 0.4 E. The E button is found next to the 4. It has an exponent of 4.1. So that's 24,136. It's approximately 24.136. All right, with this one, we're not worrying so much about graphing it. All right, this is an exponential equation, which would do something like that. It has a negative value, which would have it reflect over the y-axis. Then it would translate 2 units to the right and 1 up. So it would end up looking something like that. Okay, so your asymptote is going to be y equals 1. Your domain is all real numbers, and your range is greater than 1. We're not graphing. We're not worried about the exact values. I just did a quick sketch on what was happening with an exponential equation. The negative for the r reflects it, and then we have our translation. Your parents invest $5,000 in a bank account for you to start for college at a rate of 2.35%. How much will be in it after 4 years? So monthly. So if we're going to compound it monthly, this is A equals P, 1 plus R over N, and T. That is our compound interest. This is compounded. So how much is going to be in the account if you start with 5,000, 1 plus your interest rate, so 0.0235, monthly would be 12, and you want to see this after 4 years, so 12 times 4. So we're going to take our 0.0235 and we're going to divide that by 12. We're going to add the 1 to it. So now we have 1.002 to the 48. Now I'm going to use this exact value. This is going to make a difference. If you just use that, you're going to get dramatically a different value. Okay, so we're going to take that and raise it to the 48th power and times it by 5,000. So you're going to have 5,492. Okay. Now, if you compound it continuously, that is the Pert formula. And the RT are the exponents. So we're starting out with 5,000. Exponential, your exponent, well, it's E because it's compounded continuously. Your exponent is 0.0235, and you're doing this for 4 years. So we have 5,000 to the E, and the E is next to the 4, raised to the power of 0.0235 times 4. Okay, I'm kind of surprised it didn't increase any bigger than that, but it's a short period of time with not a very exciting interest rate. All right, in 2 years, you want to have $5,000 in your account. Find the amount you should deposit if the account pays 3% compounded continuously. So if it's compounded continuously, you're using that formula. You want to have $5,000 in your account. How much should you put in if your interest rate is 0.03 and you're leaving it in there in 2 years, for 2 years? So we can figure out what E to the 0.03 times 2, that gives us 5,000 P to the 1.062, but I'm going to use the whole value. This won't make a big difference because we're not raising it to powers, but we take 5,000 and we divide it by our previous answer. So we should get 4,708. Last side, we're going to factor these, some good factoring questions. All right, this has 4 different pieces to it, so we're going to factor by grouping. So we can factor out the x squared, and that leaves us 7x minus 2. Bring down your sign. Factor out a 25. That leaves us a 7x and a negative 2. A negative and a negative make a positive. So notice what's inside the parentheses. They're exactly the same. So this is x squared minus 25 and 7x minus 2. Well, it looks like we're done. We factored it. But this is also the difference of two squares. So we can factor that apart by taking the square root of both sides. This one is not factorable. You have to factor it completely. This is a quadratic. Okay, it's x to the second power. This is a trinomial that has 3 parts. So you could use a guess and check format on this if you liked. What multiplies to be 15? Typically we would do 5 and 3. Now there's multiple ways to do 24. This is a tough one to guess and check. But let's see if we can trip over it, huh? Let's try 6 and 4. If we did 6 here, we get 30, and 4 would be 12. That could get to 18. That didn't work. If we did 4, which is 20, and oh, that did it. 4 and 6, this makes 20. This makes 18. So this is a negative 20 and a positive 18. That makes negative 2. So that's called guess and check. I find that to be a little tough for some people to be real accurate on. But again, dealing with this one where you had to multiply to be 24 times 15, you had to be 360. That added to be positive 2. You knew they had to be 2 apart from each other. That would be a lot of factors to go through there before you could figure out exactly what that was going to be. So that can be a bit challenging also. If you wanted to continue that, we know that 10 times 36, that makes 360. Let me give you a little hint on what we can do. We can do y equals 360 divided by a continuous number, and we've jumped all the way to 10, so we got 10 and 36. We've got 12 and 30. That's not 2 apart from each other. We've got 15 and 24. That's not 2 apart from each other. But 18 and 20, that's 2 apart from each other. So that's going to be a negative 20 and a positive 18. So if you were going to do this a different way, you could do 15x squared, bring over your 18x, bring over your negative 20x, and bring down your 24. And here we could use factor by grouping. Factor out your 3x. That would leave us 5x plus 6. Bring down your sign. Factor out your 4. That leaves us with a 5x plus 6. And our answer, same thing we had before. Remember, the order doesn't matter, but there you are. So this was factor by grouping. It was a process, and if you know your numbers, kind of a tough one because the numbers are so big. This was your guess and check, but it's a challenge. We could have tried 8 and 3, 12 and 2, many different ways to make 24, but this was the only one that would have worked. All right, this has a common GCF in it. It looks like 2 might go into all of those numbers, a 2x. So that leaves me with 20x squared and a 7x and a negative 3. No GCF is in that. So you could do factor by grouping again, or you could go for the guess and check. Again, it could be 10 and 2, it could be 5 and 4. I'm just going to guess that it's 5 and 4. That's a very typical way to do it. So if this was your 3, that would be 15 and 1. That wouldn't get you to 7. If that was 5 and 12, 5 and 12 would do it. 5 and 12. So if you have a positive 12 and a negative 5, that makes positive 7. Here we have the fourth power, but this is still a quadratic because that b term is squared. It's half of the 4. So we're going to treat this just like a normal quadratic, but we're going to use x squareds because they add together to be the 4. When you multiply their bases, you add the exponents. So this is going to be 5 and 6, a negative and a positive. Nothing else to factor there. Good luck, everybody.